the multipliers, the counter current multipliers are done by the loops of Henle. Okay. Now, there are two kinds of nephrons in the kidney. One is the cortical nephrons, the other one is the juxtamedullary nephrons. Okay. See, for example, if this is a kidney, this area is the cortex, this is the cortex, and this is the medulla, right. There are nephrons which has got short loop of Henle like this. These are the cortical nephrons. Okay. I am just drawing one or two nephrons for your reference. Okay, but there are millions. There are few nephrons whose loop of Henle is going up to the medulla. These are called as juxtamedullary nephrons, right. So, the cortical nephrons are predominantly involved in the transport mechanism, that is your reabsorption of various solutes and the water and whatever. All sort of transport mechanisms or reabsorption mechanisms are taken care of by this cortical nephrons. Whereas the function of this juxtamedullary nephron is to create high osmolar gradient, hyperosmolar gradient in the renal interstitium. In between this nephron spaces, you have got the medullary interstitium. So, here there should be high osmolar concentration. The creation of such high osmolar concentration is done by this juxtamedullary nephrons. That is the prime function of the juxtamedullary nephrons. Okay, and you also have a different so I should actually draw the blood vessels in red color and but on the reverse. Okay, so you have got the vasa recta parallelly. Maybe I will draw like this. So, the blue color one is the veins, vasa recta. Okay. So, parallel to the juxtamedullary nephrons, you have got that long loop of vasa recta, blood vessels. These are nothing but the peritubular capillaries, okay, that are also present near the juxtamedullary nephrons. So, whatever the hyperosmolar gradient that is created by this loop of Henle of the juxtamedullary nephrons is maintained by the vasa recta. That is the idea, okay. So, in this picture it is quite clear. See, these are the cortical nephrons which are present. This is the cortex and this is the medullary zone, okay, outer medullary zone and the inner medullary zone. And you can see here the cortical nephrons has got a short loop of Henle which is just ending at the junction between the cortex and the medulla here, okay. So, it ends here itself in the outer zone itself, okay. So, it is very short. Whereas the juxtamedullary nephron, you can see here the nephron, the loop of Henle is very long and it reaches the depth of the medulla. It has reached actually the inner zone of the medulla. And you can see the blood vessels, the vasa recta, here is the arterial component. These are nothing but the specialized peritubular capillaries, right. So, the arterial component and the venular component which is just lying parallel to the loop of Henle. You can see here, this is the parallel loop of Henle. So, this is the specific anatomical arrangement that is present for this creation of this hyperosmolar medullary gradient.